I've been creating Next.js content for years, and recently I've built a YouTube playlist that's accumulated close to 4 million views. Through all of this, I've seen how understanding Next.js file conventions is the key to using the framework to its full potential. In this video, we will break down the 9 special routing files in Next.js 15 app router. For each file, I will explain what it does, why it matters, and how to use it. By the end of this video, you will have a complete understanding of the app router's special files and a place to come back to when you need a refresher. Let's start with page.tsx. Page.tsx contains the UI components that is unique to a route. This file is crucial because it works hand in hand with Next.js folder structure to create your routing system. Let's head over to VS Code and understand this better. I have with me a Next.js 15 project. When you create a new Next.js app using create next app, you automatically get one page.tsx file in the app folder. This is your home page available at the root URL, localhost 3000. To create a new route, simply add a page.tsx file in a special folder within your app folder. The file's location will directly correspond to the URL path. For example, app/blog/page.tsx with a React component will create a route at /blog. The component JSX becomes the content. You can create nested routes by adding more folders. For example, app/blog/archive/page.tsx with a React component will create a /blog/archive route. For dynamic routes, use square brackets in the folder name. For example, app/blog/ within square brackets slug/page.tsx with a React component will match routes like /blog/ my first post, second blog post, etc. The slug part of the path is a dynamic segment that can be accessed in the page component as a prop. So from params, we extract slug, which we render as part of the JSX. Just remember, page.tsx must default export a React component that defines the content of your page. Next, we will dive into layout.tsx. Layout.tsx creates a shared layout that wraps around your page content. This file is essential for maintaining consistency in your application and improving performance. It allows you to create reusable layouts, reducing redundant code, and ensuring a cohesive user experience across your site. Let's head over to VS Code and understand this better. A Next.js app created using create next app will automatically get a layout.tsx file in the app folder. This is your root layout, which will wrap around the entire app. So we have the HTML and body tags that wrap around children, which represents page.tsx. In this file, you can add elements like a header and navigation that should be consistent across all pages. Back in the browser, we can see our header with the 2 navigation links. We also see the footer at the very bottom. When you navigate between pages, the layout remains the same, so header and footer, and only the page content changes. To create a layout for a specific route, add a layout.tsx file in the same folder as your page.tsx file. For example, in app/blog, we can add layout.tsx. This blog layout contains 3 links to /blog/1, 2, and 3, which correspond to our dynamic route segment. The layout will render the children prop, which corresponds to page.tsx in the blog folder. The blog page will also inherit the root layout when we visit localhost 3000/blog. We have the header links from the root layout as well as the footer. But then for the blog itself, we have a layout with post 1, 2, and 3 corresponding to these list items. When we click on post 1, we navigate to /blog/1. We see the page.tsx content, which is the slug itself, 1. But the blog layout links stay in place, post 2 and post 3. It is important to note that layouts are persistent across routes in their scope. This means they don't re-render when we navigate between pages, leading to better performance. You can verify this by simply adding a console log statement in layout.tsx and navigating in the browser. We see the GET requests for the different routes /1, /2, and /3, but we just have the one blog layout rendered. Just remember, the layout.tsx file must default export a React component that accepts a children prop, which will render the unique content of a page. Now, let's dive into template.tsx. Template.tsx creates a reusable template that wraps around your page content. This might seem familiar to layout.tsx at first glance, but there is a key difference. Unlike a layout which persists across routes, a template gives you a fresh instance every time the route changes. Template.tsx is crucial when you need a reset between routes. It is perfect for scenarios where you want to reset state, trigger enter-exit animations, or run effects that should fire on every route change. Let's head back to VS Code to see template.tsx in action. Now you can create a template.tsx file in the app folder, which will be applied to every route in your application. However, it is more common to create a template file in a subfolder, applying only to the pages within that folder. For example, let's use Framer Motion to add page transitions to our blog section of the app. Run the command npm install Framer Motion. Once the installation completes, I will begin by editing the layout.tsx file in the blog folder and define the layout with a Framer Motion component for page transitions. Make sure to add the use client directive at the top. In the browser, when we navigate to the blog page and click on the individual links, we don't see the page transition. The number changes almost instantly. That is because a layout.tsx file does not re-render when we navigate between pages. Let's rename layout.tsx in the blog folder to template.tsx. I will also update the slug page.tsx to contain more text to make sure we can see the page transition well enough. In the browser, when we navigate to the blog page, we can see blog posts sort of fade in. When we click on the links, we see the page transition. This is because a template.tsx file, unlike a layout.tsx file, does re-render when we navigate between pages. A very important distinction to make. You can, of course, combine templates and layouts to create more complex yet performant structure. Remember, templates are the exception, not the rule. So stick with layouts for most of your app structure and bring in template when you need that fresh start magic. Let's now take a look at our fourth special file, loading.tsx. Loading.tsx creates a loading UI that is shown while the content of a route segment is being loaded. It leverages React suspense under the hood to automatically wrap your route segments and pages. Loading.tsx is crucial for improving user experience. Instead of users staring at a blank or partially loaded page, they see a loading indicator or skeleton UI. This instant feedback makes your app feel more responsive and can significantly reduce perceived load times. To implement a loading state, create a loading.tsx file in the same directory as your page.tsx file. Next.js will automatically use that file to show a loading state while the page content is being loaded. Let's create a loading state for our blog posts page. So in the blog folder, create a new loading.tsx file. Here, define a simple loading component. I'm using Tailwind CSS classes to create a simple spinner. To induce a loading state, we can add a delay to our blog component. So blog page.tsx, we're going to add a 2-second delay. The easiest way to do that is to convert this blog page into an async component with a promise that resolves after 2 seconds. So export default async function, and we await a new promise that resolves after 2 seconds. Back in the browser, when you navigate to the blog page, you see the loading state, and after 2 seconds, we see the page.tsx content. Now we have a simple loading spinner, but in a real application, you might want to use a more sophisticated loading UI, like a skeleton screen that matches the structure of your blog post. Please note that loading.tsx is used for both static and dynamic routes. For static routes, it will only appear for an instant during client-side navigation. For dynamic routes, or when fetching data, it might be visible for longer periods. You can also create a loading state at the root level, so within the app folder, loading.tsx, which will serve as a fallback for all pages that don't have their own loading state defined. Lastly, loading states work hand in hand with suspense boundaries. So you can create more granular loading states by wrapping specific components in suspense. For example, we could define a featured post component that fetches data and displays it. Within the blog folder, create a featured blogs component that renders a list of featured blog posts, for example, and this is rendered after a 2-second delay again. In page.tsx, we can import suspense from React, featured blogs from featured-blogs page, and invoke the component with suspense and a fallback state. Back in the browser, when we load the blog page, we see the loading state for the page component for 2 seconds, and then the loading state for the featured post component for another 2 seconds. Let me repeat this. Blog, 2 seconds, 2 more seconds, and we see featured blogs. So loading.tsx, coupled with granular suspense boundaries, gives you a ton of flexibility to create a smooth user experience. Let's move on to our 5th special file, error.tsx. Error.tsx creates a custom error UI that is displayed when an error occurs within a route segment. Error.tsx allows you to display custom error messages, potentially offer solutions, and even provide a way for users to recover or report the issue instead of showing a generic error page or crashing the entire app. This can significantly improve user experience and help maintain user trust when an error occurs. To implement a custom error UI, create an error.tsx file in the same directory as your page.tsx file. Next.js will automatically use that file to show an error state when an error occurs within that route segment or its nested route segments. Let's introduce an error into our blog post page that randomly throws an error 50% of the time and create an error boundary to handle it. So within the blog page, create a new file, error.tsx. Here, define a simple error handling component. The complete code for this project is available on my GitHub repo, and the link to that is in the description down below. So please don't worry about having to pause the video to write down the code. Now this error component here does a few important things. First, it is marked as a client component with use client directive because it uses hooks and interactivity. Second, the component receives the error as a prop, which is logged to the console. In a real application, you might want to send this to an error tracking service. Third, it displays a user-friendly error message, error loading blog. Fourth, it provides a try again button that attempts to recover by re-rendering the entire segment. And to re-render both server and client components, we use the start transition function from React with a combination of reset, which the component receives automatically as a prop, and router.refresh from the useRouter hook. In the browser, when we navigate to /blog, depending on the random value, we might see an error. So I'm going to refresh a couple of times till we hit that error state. And there we have it, error loading blog, and we have the try again button. When we click on try again, the route segment will re-render, and depending on the random value, the error disappears. We were quite lucky, the random number generation was in our favor. We only had to re-render once for both scenarios. Now we can also create an error boundary at the root level, which will serve as a fallback for all pages that don't have their own error handling defined. So I can copy error.tsx and paste it in the app folder with a minor correction to the JSX. However, it is important to note that this error.tsx will not catch errors occurring in the root layout. For those, we will need to use the global-error.tsx special file, which we will cover next. Global-error.tsx creates a global error UI that catches and handles errors at the root of your Next.js application. It serves as a catch-all error boundary for your entire application. This file ensures that your users always see a meaningful error message, even if something goes catastrophically wrong at the highest level of your application. I'm going to comment out the random error throwing in our blog page. Now, to introduce an error in our root layout, I'm going to add a special wrapper component that throws an error. So within the app folder, I'm going to paste wrapper.tsx. You can find this code on my GitHub repo for this video. Wrapper.tsx has a error simulator component, which is a simple button that will throw an error when you click on it. The wrapper component will wrap the component with a border and include error simulator when rendering that component. Back in layout, wrap the children with the wrapper component. Next, we will add a global-error.tsx file in our app folder. This file should export a React component that will be rendered when an error occurs in the root layout or any of its nested routes in the absence of another error boundary. I will copy and paste the code, but there are two important differences to highlight in how a global error.tsx file works compared to error.tsx. We can see our wrapper component with the simulate error button, and when we click on simulate error, we don't see the global error UI. That is because global-error.tsx is only enabled in production. In development, our error overlay will show instead. Let's build and run our application. In the terminal, Ctrl+C, npm run build, npm run start. Back in the browser, click on simulate error. Now we still don't see the global error UI, but we don't see the error overlay either. This is because rendering the HTML and body tags in the DOM is essential. When we replace our root layout.tsx file with global-error.tsx file, we need to make sure to add the HTML and body tags. They are missing in our global error file. Let's fix this. So HTML and body class name is equal to inter.classname. Everything else remains the same. Let's rebuild our application. npm run build and npm run start. Refresh the page, simulate the error, and now we see the global error UI. Something went wrong and a refresh button. So the global-error.tsx file works only in production, and it requires HTML and body tags to be rendered. These two differences are very important to remember. It's also important to keep your global error component as simple as possible. Avoid using shared components or complex logic, as these might themselves cause errors. Stick to basic HTML and CSS to ensure it always renders no matter what. Global-error.tsx is your last resort. It should only kick in for severe app-breaking errors. For everything else, you need a more specific error.tsx file. Let's now move on to our seventh special file, not-found.tsx. Not-found.tsx creates a custom UI for 404 not-found errors in your Next.js application. It is automatically invoked when a route segment can't be found or when the not-found function is called. The not-found.tsx file is crucial for providing a better user experience when users encounter pages that don't exist. Instead of a generic browser default 404 page, you can create a branded, helpful page that guides users back to valid content. This can significantly improve user retention and maintain the consistency of your app's look and feel. To implement a custom 404 page, you can create a root level not-found.tsx file in your app folder for a default 404 page across your entire application, or you can place it in specific folders for more targeted 404 pages in different sections of your app. First, let's create a not-found page in our app folder and default export a React component. In the browser, navigate to localhost 3000/test, a route that doesn't exist, and we can see the custom 404 page. Not found, could not find requested resource, return home. The JSX corresponding to our not found page component. To make this UI better, you could include links to main sections of your site and maybe a search bar to help users find what they're looking for. You can also use this opportunity to inject a bit of personality into your application. Many sites use their 404 pages to showcase their brand's humor or creativity. We can also programmatically trigger a 404 page by calling the not-found function. Let's do this in our dynamic blog post page. At the top, we import not-found function from next/navigation, and if params.slug is equal to the string not found, we call the not found function. In the browser, when we navigate to /blog/not-found, we see the custom 404 page. As an exercise, I encourage you to create a custom 404 page within the blog folder to understand how specific pages can have their own 404 pages. Not-found.tsx is your chance to turn a negative experience into a positive one. Make it engaging, informative, and on brand to keep users exploring your application. Next, let's dive into default.tsx, a file that plays a unique role in Next.js parallel routing. It is an advanced routing concept, so don't worry too much if you don't understand it right away. Default.tsx provides a fallback UI for parallel routes when no specific match is found. It is crucial for creating smooth user experiences in complex routing scenarios. When you're working with parallel routes, there might be situations where one part of your UI doesn't have corresponding content. Instead of page not found error, default.tsx allows you to display meaningful fallback content. To give us a head start, I'm going to copy-paste a dashboard folder that consists of parallel routes. So within the app folder, we have a new dashboard folder. Let me give you a quick rundown of what we have here. First, you should know that the parallel routes feature allows you to simultaneously render one or more pages within the same layout. In our case, layout.tsx has a few links to /dashboard, /dashboard/settings, and dashboard/analytics. And then we have the main children prop. This renders page.tsx, which is dashboard main content. But we also have a panel slot prop that is rendered alongside the children prop. Panel here refers to the @panel folder. This has two folders, analytics and settings, each with their own page.tsx file. Analytics panel and settings panel. So our layout is not only rendering page.tsx in the dashboard folder, but it is also rendering a page.tsx from either the analytics folder or the settings folder based on what the URL is. So we are parallelly rendering multiple pages in one layout. This is how parallel routing works, and it gives you the ability to have your own loading and error files for the panel folder. But what is important is in the browser, if we navigate to /dashboard, we see a page not found UI. This is because the panel slot prop does not know what content to render for the URL /dashboard. It can render analytics and settings for /dashboard/settings or /analytics, but for just dashboard, the parallel route does not have content to render. We can fix this by adding a default.tsx file in the panel folder. So new file, default.tsx. We're going to export a React component called default panel that simply renders default panel content text. This will serve as a fallback UI if no specific content is found for the particular slot. In our case, when we navigate to /dashboard, panel will render the default page. So back in the browser, we can see for /dashboard, we have dashboard main content, which is the actual page.tsx. But for the panel on the right-hand side, since there's no matching analytics or settings, we see default panel content. If we navigate to settings, the URL is /settings and we see settings panel. If we click on analytics, the URL is /analytics and we see analytics panel. This is the role default.tsx plays in parallel routing. But there is a catch. If we reload /dashboard/analytics, we would see the 404 page again. This is because the dashboard folder does not have default content to render for this URL. We can make a copy of page.tsx and rename it to default.tsx. Now we can see dashboard, settings, analytics. But if we refresh, our route is not broken. The content from default.tsx is served. I understand that default.tsx is a bit complex, but it is a powerful feature that's only used in the context of parallel routing. It won't have any effect in regular routing scenarios, so if you don't understand it right away and you don't need it, you can safely ignore it. Alright, let's wrap this video up with our 9th and final special file, route.ts. It is a powerful file that bridges the gap between your front-end and back-end in Next.js. Route.ts allows you to create API routes directly within your app folder. It is used to handle HTTP requests and define custom request handlers for specific routes in your Next.js application. Route.ts is essential for building full-stack applications with Next.js. It enables you to create serverless API endpoints right alongside your front-end code and gives you fine-grained control over how your application responds to HTTP requests. Let's head over to VS Code and understand this better. To implement a custom route handler, create a route.ts file in any route segment of your app directory. Imagine we want to create an API endpoint for a simple to-do list. We'll create a route.ts file in app/api/todos. The file should export HTTP methods such as get, post, put, etc. as named functions. Let's break down this example. We have defined 4 HTTP methods: get, post, put, and delete. The get method returns all to-dos. We have 2 of them, learn Next.js and build an app. The post method adds a new to-do. From request.json, we extract data and assign data.title to a new to-do title. We push that to our to-dos array. Respond with the status of 201. Similarly, the put method updates a to-do given an ID, and the delete request removes a to-do by its ID. This file doesn't render any UI components. Instead, it's all about handling data and server-side logic. Now we can verify the GET request in the browser by navigating to localhost 3000/API/todos. We see the to-dos in JSON format, learn Next.js, and build an app. To test the other methods, we can use a VS Code extension called Thunder Client. For the post request, we set method to post, the URL to localhost 3000/API/todos, and add JSON body. Hit send, and we see status 201 created. The ID is 3, title is new to do, and completed is false. Rerun the GET request, and we see the new to do in the response body. Very simple to get started with API endpoints. I encourage you to test the other 2 methods, put and delete, to make sure you get the hang of it. Now, a very important thing to keep in mind is that you should not place a page.tsx file in the same folder as your route.ts file with a get handler function. That would cause a conflict. So there you have it. These 9 special files are the building blocks of the Next.js app router. When you understand how they work together, you'll be able to create some seriously powerful and efficient web applications. Remember, you don't need to use every file type in every project, but understanding each one gives you the power to choose the right tools for your specific needs. If you found this breakdown helpful, please don't forget to like, subscribe, and check out my full Next.js playlist with close to 4 million views. I will see you in the next video.